Hello everybody, I'm your host Hal Curtis and I'd like to welcome you to The Space Industry by SatSearch, where we share stories about the companies taking us into orbit. In this podcast, we delve into the opinions and expertise of the people behind the commercial space organisations of today who could become the household names of tomorrow. Before we get started with the episode, remember you can find out more information about the suppliers, products and innovations that are mentioned in this discussion on the global marketplace for space at satsearch.com.
Hello, everybody. This is Narayan, one of the co-founders of SatSearch, who's standing in for Hyvel, who's briefly on a break. Today, we're going to be talking about hyperspectral imaging, thermal imaging, LiDARs, and AI that is all evolving in this industry with SatSearch member company Cosine. Cosine develops and builds measurement systems for its customers in several sectors, including scientific, industrial, medical, environmental, food, semiconductor, and space applications. We have with us today Marco, the managing director, Ivan, the sales engineer, and Nathan, research scientist at Cosine, bringing in their insights into this particular podcast episode. Now, let's begin the episode by briefly learning a little bit more about Cosine as a company, as well as a brief background to hyperspectral imaging and how it has evolved through the last couple of decades to where it stands now.
Sure, yeah, thanks a lot for the question. And indeed, very happy to be here and to discuss about these topics and also to present a bit the company that has also been around for quite some time. Now it's a quarter of a century. And my name is Marco Esposito. I'm the managing director of Cosine Remote Sensing. That is part of the Cosine group that is doing, indeed, a number of activities in space, but also non-space. And the company was founded in 1998, indeed 25 years ago. And since then is evolving a lot as a company, let's say, busy building measurements and remote sensing solutions for space, for planetary science, for Earth observation, also for astrophysics. So these are the three actually main markets we cover with our technology instrumentation. And if you talk about hyperspectral sensing, this is something we started working on early 2000 actually. So when we were basically tasked by European Space Agency, the Science Department, to see what are the new technologies, what were the new technologies back then that actually are still very applicable nowadays, that would allow, let's say, a planetary science mission to become more efficient, the information content of the data to be more valuable for the science community, at the same time make these kind of instruments very compact, cleverly miniaturized in order to, indeed, for planetary science, like for small satellites, for Earth observation, one of the main requirements is to swap a very minimum envelope, minimum power consumption, and then still be able to deliver good data content. And so we have researched for quite a number of years how to miniaturize a number of technologies. This includes spectral imaging, of course, but also LiDARs, also spectrometry, also thermal sensing or infrared sensing more generally. So starting really from near infrared, short wave, mid wave, up to thermal wave, so long thermal imaging. And these all together, back then, we were looking at science cases or let's say use cases like Jupiter, actually Europa, one of the satellites of Jupiter, and then also Mercury, so completely two different colds, a bit far from the sun. At the same time, the radiation environment is very harsh, while the other one is closer to the sun, so the thermal environment is very harsh and radiation is a bit less. So we had to design and to build such a technology that would survive these completely different environments. And let's say to keep it short, so we have been developing indeed how to integrate spectral imaging together with LiDAR based on single photon counting and stereo imaging together with infrared spectral imaging all together. And we managed to do that with indeed suite of instruments that will not exceed something like around 10 kilos, and including all these kind of instrumentation. Then, let's say, all over the years, this became a bit more the case for Earth observation as well, with the advent of small satellites. Also, the requirements were not anymore, let's say, like the institutional missions really look at the best in class, whatever it costs, whatever volume it takes. Let's pick the best and let's go for it for 10 years or 20 years. And then let's launch, let's cross fingers the launcher doesn't blow up everything. So indeed, also there come to let's make it more, let's make it efficient. And let's look at these kind of measurements from a different angle. So let's make it more reliable at system level, so a constellation instead of on a single unit, and so on. So hyperspectral came in, actually I have to say, at least in Europe, if not worldwide, with Cosine collaborating with ESA, how to make hyperspectral available to small satellites. So before us diving into it with ESA, there were a few missions, like we know the ones that were really demonstrating Hyperion or a few others done by NASA that we delivered some data again with the large satellites. So actually, we came in and with ESA, we came up with one of the first futurized spectral sensing systems with a lot of focus for the onboard intelligence as well, because one of the enablers is actually making sure that the huge amount of data you generate with this technique are actually usable, are actually it's possible to use them, because to downlink back then, but still nowadays, is difficult because we generate gigabytes per acquisition, it means terabyte per orbit very quick. So how to really make sure this bottleneck is not there? So we actually addressed that very aggressively since the start. So we started 10 years ago. And with us a little bit, the community moved on a little bit, because in 2018, we were the first demonstrating to fly a spectral system of just a couple of kilos with a huge onboard processing capability. We demonstrated that it's possible to actually process them in space. And with that, from multispectral, people start looking really into hyperspectral more with a view on the operational possibility, because before, still nowadays is a very difficult technique, because since there are no many missions operational, so also the user and the valuers are not yet in the position to really plan a business. So it's still in this transaction phase where people start to rely more on it, but still is not fully there. But the forecast is very bright, because there are, of course, already some institutional missions, and also ESA is moving with the Chime, and this makes things a bit more solid. And there are a number of companies working on hyperspectral systems. So not only, of course, not only cosine. It's actually now becoming indeed more a market. Before we were really a precursor, now it's becoming a bit more indeed. Not yet, but it's going to direction. And then if you talk indeed, what is the added value compared to multispectral? I usually try to be very basic on this. So if you use multispectral, it's like your eyes. You can process a few colors. So your eye can process actually 3 colors. With multispectral, you can use a bit more. With hyperspectral, you're actually able to process your scene with many colors, so hundreds of colors. And all these are information that are not visible by the human eye, are embedded in your object, in your target, and you can actually use that in combination with normal imaging, high resolution imaging. The trick, of course, is to make sure that your spectra, so your 100 colors, are actually of a good quality, because there are, of course, now many companies building 5 meters, 10 meters hyperspectral. That's, of course, very challenging because of what I'm saying. So you need really to make sure that your pixel size, your radiometry, is actually well balanced with the resolution. So with that, we designed a few systems with ESA, making sure that is the backbone quality of the data. It means good radiometry, very clean spectra, and then you can use techniques to really look into your target with a different additional axis compared to normal imaging or to multispectral imaging. So you really detect. If you talk about agriculture, plant, you can look at also water quality in a much better definition. But what means much better definition means actually you can detect effects or phenomena much earlier in their progress. With multispectral, you have a few colors. Let's make the example of a fruit, an apple, a lemon that becomes bad. So it's changing from, let's say, the lemon from yellow to more orange or getting bad. You will see with multispectral when it becomes that bad, but at that moment it's actually late. The lemon is gone. So if we have spectral, since we have many more colors to look at that are spectral bands, you can actually see this phenomena acting much earlier in the process. So you can actually then act much earlier and actually recover the lemon. Now it's a very basic example, but this scale up to big with huge areas of agricultural fields that are actually making a lot of economy on it. So this becomes a very relevant phenomenon. Perhaps I'm taking too much time on this, but that's a little bit short, let's say, view on hyperspectral, a little bit of cosine, how is in that. And the cosine is actually also capable to intercept these new technologies, these really disruptive ones. This is now example of hyperspectral. We are doing this also in many others fields, like ladders. It's becoming thermal imaging ladders. These are for us the next 2 big ones that will make some difference in the market.
Thank you so much, Marco, for that introduction. So obviously, we've known cosine for a while, and I know that you benefit from working across different domains, including places like high energy optics, in inspection systems. You probably work across different industries, obviously, as well, which makes it very interesting because you can gain a lot by working in those industries and bringing some of those facilities as well as knowledge back into the space industry, or taking things from the space industry to those places as well. Obviously, your work in across these sectors allows you to also have possibly different product lines, right? You just mentioned about hyperspectral imaging. We also have thermal imaging, lidars, and other products that are listed by cosine on SatSearch, for example. Generally, I think given that you have this broad focus on high energy optics inspection systems, remote sensing, what kind of facilities does cosine host, and what kind of product lines are you able to support across the space industry?
Yes, Narayan. So this is a big, let's say, asset for organization, being able to act on different markets, you just said. So indeed, high energy missions, and then we do the optics for that, remote sensing for space, planetary science, Earth observation, and then what we call inspection systems means deploying smart, cleverly miniaturized instrumentation for in the field, in the factory, for food, for pharma, for oil and gas, for markets where indeed is easier, or not is easier, but it looks easier, let's say, to deploy your technology. But actually, there are other issues there that may become even harder than something in space. But in general, indeed, this cross-fertilization between the different units that we have, and then it's different markets, this makes our products valuable compared perhaps to other options on the market. So if you look at indeed the possibility to first 10 years ago, we were really bringing technologies we developed for ground, for terrestrial application into space. That is actually how some of our Scout product lines came up back then. And now this is a bit reversed, or actually there are two ways. We're also able to spin off technology from space into non-space. And this is a continuous back and forth, making always the best product out of it, the most efficient, because then becomes, in terms of quality price ratio, becomes always the best. Of course, we are not just a manufacturing club. We are not at all a manufacturing club. We also manufacture in series now period for Earth observation. So I think Ivan will tell something about it in a moment. But what we are, of course, known for is to really come up with orthogonal solutions to problems that have been addressed always in the same way. And this is because we act in different fields. Sometimes we are tasked to find a solution in a field where we never worked in, and actually they call us because of that. So we don't know how the others are doing it. We are not polarized already to act a certain way. We are not offset by how people do it. Used to do it. So we came up with completely different solution, orthogonal thinking, we call it, and we came up with something that people say, oh, so that was a way we never considered that actually is better for this and that. Sometimes this can be worse for other aspects, but you can trade it off and come up with the best for the application. In the end, we always start from the application. For that, every time that someone calls us, they don't know us and they believe that we are just a camera manufacturing, that we are not. We are not a camera manufacturing company. They came up and asked, yeah, can you give us a price? And we always reply, we need to talk because we need to know what you need to do, what is your application, because we have in-house a bunch of scientists that are used to understand the problem at the roots. So what do you need to measure? This, okay, then we can of course offer our off-the-shelf product that we have quite a few that actually we can sell just in a few months. But then we can tell you, okay, with this you can do that, but most likely you have to use this in this way. You have to also do this at this option, or actually we can give even something else you were not thinking about it, or we can help you, let's say, also in the science part. So we are quite a complete science-based organization. I always like to use, let's say, we like to build system that are scientific instruments for operational use. So we really go down to the operations, but we make sure that the content is very high. So again, the example of you go just for the best resolution you can find, people should know that indeed, in the end, you sacrifice a lot of other figure of merit that are sometimes more important. Hyperspectral is actually, back to hyperspectral, is good if you're able to have a very clean spectrum, means enough resolution, radiometric resolution, radiometric noise ratio to have a clean spectrum. If you just focus on 5 meters GSD or 2 meters GSD, and then you see all, let's say, blurred in terms of spectral content, the value of spectral imaging is gone. Better if you focus then on high resolution imaging with perhaps panchromatic or a few bands, then you can look geometrically at your problem, but we look spectrally. And also we do polarization. We do many things. And this again, so in the food market, we have been very involved. How we work is that we have a kind of IP, a cosine, a core of brilliant scientists that come up with revolutionary solutions for measurement problems. And we work on it thoroughly and also 360 degrees, I just said. So we look at the full chain to make sure that that the customer actually gets what needs. And then once we have a bunch of technologies we're working on, I just mentioned, but when we find a good combination or a good match between technology and market, usually we spin off a new organization. And that organization can focus on the market for that technology. For example, the food was one of those. So we spin off a company that is addressing only the food sector. And now it's an organization is actually doing quite well in that market. Still a cosine company. Of course, with time, also other shareholders can come in, but in general, it still keeps to be a cosine company that is doing only that. We had also another example in the past. We developed quite a number of scopic camera for the space station. We did quite for looking at the interior of the space station, but also outside to help the operations of the robotic arm and other things in 3D. Also for supporting the training of the astronauts on ground, so to reconstruct a virtual model on ground. So we developed, I think, three series of copy camera with actually real-time streaming of the data down, let's say, to Earth, but down even in ESA, in the Erasmus building, on the main big screen there. So that was quite a huge development. Actually, was crossing when the market were picking up in the stereo for the user market, for the 3D, let's say the 3D televisions in the house of everyone. And at that moment, we actually came up with a new company. It was called 3D One at the time, that was actually able to spin off ISS built cameras into the consumer market, actually for movie makers. So we built quite a number of cameras that were actually competing with big firms like Panasonic, like Sony. With time, we sold a few. With time, then we moved from full camera system into OEM to actually serve our competitors. That was a better move because these big firms are very, of course, powerful ones. They understand competition. They also push the throttle. But this is to say, so there are a number of examples we work like this. And then in the end, if a customer needs a solution, usually, if they come to us, there's a good chance that we can find the good one, the good solution.
Great. Thank you so much again, Marco, for that really extensive overview. I think there's very little companies that we see that have the depth and the breadth of capabilities that also work across industries that Cosine brings, for example, in our experience at least. What you also mentioned is quite interesting, which is also a bunch of very highly trained scientists and engineers working together to solve particular problems. I'd like to bring in Ivan at this particular point of time to talk really more about what happens at this point of time in the new space industry, which is obviously if hyperspectral imaging is taking off and there's some constellations as well as some missions that are going up and a number of companies looking to build several satellites that carry some of these imagers. So this is a bridge towards going from being typically scientists working on one instrument and then looking at creating new variations of that instrument or probably bettering that instruments every single point of time to moving on to more of a productionization approach so that you can satisfy building up of one such constellation or several such constellations, for example. So I'd love to hear Ivan talk about what are the typical strategies, challenges when it comes to productionization, as well as how would you move on towards having a recurrent production for Hyperscout as a line, for example?
Hi, thank you, Narayan, and lovely to be here on this podcast as well. And thanks to Marco for the intro and general info on the company itself. When it comes to production, our facilities, we aim to construct measurement systems tailored to our customer specifications, so encompassing both hardware and software. We aim to integrate our measurement systems into their existing setup, whether it's a laboratory automation system or a field application. Our systems also come fully documented with options for instructions on site or in orbit commissioning and training as well. So in terms of batch production, we aim to increase our consistency and reliability as multiple instruments and subsystems can be tested and integrated at once. So this shortens the lead time significantly and reduces any potential risks as well. The production timeline for the initial units influenced by the operational environment ranges from 1 month to a year, depending on the instrument itself. So also depending on how much customization needs to be done, or if it's what we aim for and that's an off-the-shelf product. In order to minimize the lead time from initial order to delivery, we have taken the highest priority in pre-ordering the long lead time items from suppliers, which resulted in having some of our Hyperscale models available for delivery within 2 months from order. This being said, I can guide you through a bit of history of the Hyperscale portfolio. So the first Hyperscale 1, which was a single veneer channel, was launched in 2018 by the European Space Agency. And it was an in-orbit demonstration mission, and it was equipped as a miniaturized hyperspectral instrument based on the LVF technology, which demonstrated the capability of an instrument to deliver high-quality imagery and serve applications like, for example, land cover classification, change detection, disaster monitoring. It was the first miniaturized hyperspectral imager with autonomous processing capabilities and on-edge computing. It integrated spectral imaging with onboard processing and is designed for micro, nano, and large satellites. With an appropriate satellite constellation, you can measure any parameter anywhere and at any time. So this is why we approached batch production, to have many of these instruments available at a shorter time. So the combination of rapid price reductions and instrument miniaturization allows also Hyperscale to be a commercially viable platform for enterprise-level real-time Earth observation. This technology empowers numerous companies and organizations to utilize real-time Earth observation data for various insights and precision-making purposes. This paved the way for new developments soon enough. Hyperscale 1 was complemented with a thermal channel, creating the Hyperscale 2. From there on, many variations were made to create a complete Hyperscale product line, offering a dedicated choice for each customer application. Such, for example, our Hyperscale M is a one-use size signal channel hyperspectral imager. Then we have also Hyperscale S, which is an enhanced resolution with a similar size to our Hyperscale M, and therefore on a full thermal T-Scout. With the additional specialized Hyperscale models for deep space exploration missions, such as asteroid surface inspections, which I think Marco will cover on a little bit later.
Great. So again, there are some very interesting trends that I'd like to talk about. One, especially that is spoken a lot about nowadays, is obviously AI. The whole trend around AI, we see different patterns emerging or different types of adoption being tried in the industry. So just to give a sense to the listeners, we've seen people come up with only software techniques that people can use on board alongside the existing hardware that people are flying around. We've seen people come up with edge computers that are dedicated that people can fly. And then there is possibly what you can do, which is right at the instrument itself, because obviously you're closest to the sensor when it comes to edge computing with the instrument in itself. So I think, Marco, I think given that you have a reasonably very well trained background around this, I would love to hear about what is your take around edge computing and AI in particular, and the role of AI in all of these. And how do you see this evolving from the perspective of the industry as well as from what Cosine itself is doing?
Yes, indeed. This is a very interesting, very big topic. It's picking up a lot in our industry nowadays. So we see a lot of initiatives, as you just said, a lot of organizations working on it. Usually when there is such a big wave, means many people, see a market there, see a change possible to be made with this technology, and then everyone is running to actually try to be first, because then they hope to get the bigger part of the cake and try to be first in the markets and try to position themselves for product and services with that. So definitely is recognized now that AI in general, we all know in the era we live now, the AI is the big paradigm shift, is the big game changer here in technology in general, so not only space. And as for other indeed markets, also for space is playing a big role now. So we have been working on it since I just mentioned before, since the start of our diving into making hyperspectral possible to enable hyperspectral on small satellites with lower power, lower volume and mass available for payloads. And one of the big ones was enabling onboard processing, making sure that indeed the huge amount of data that you have, that you generate, are actually possible to be digested, to be used, to be processed. And AI plays a big role in that. So you will not have so many systems on any kind of satellites if you're not able to use the data. And we started looking how to adjust the basics, how to process this data in space, also with the help of AI, with the help of machine learning, with the help of also machine vision. Sometimes also the boundaries between the different techniques are also not easily definable. So everything is overlapped, a lot of gray areas. But yeah, we used a bit of everything of that to make sure that the data at the end are good quality, usable, and going to information ASAP. So especially we've been always working on these systems with the view on operational, making sure that what you use can be actually making a difference in whatever operational scenario. And if you see small sat, for us, it's important that they don't compete with institutional satellites in quality, because that's just not possible. So the size still matters. So if you have a big aperture of alpha meter, you cannot compete with 20 centimeters or 20 millimeters aperture or things like that. So that's just physics. The bigger, you can get much more quality, but you can still smartly use the smaller system. So that's what we always look at the angle from where we were looking at the overall development. And so augmenting what is already there. So all the big sentinels that are there for us has been always a reference. We actually have been qualified, certified as a third-party mission contributor to Copernicus, because we've been able to make our data thanks to AI as well. So we've been looking how to use AI to cross-calibrate spectral data from our hyperspace with Sentinel. And we actually got just a few percent away with AI. And that is also became a game changer, because if you're able to calibrate in orbit with AI, a system to a big one where there are much more facilities on board to calibrate, then actually you can leverage what the taxpayers are actually contributing to for the commercial mission that then is also delivering again back to the community. So that's all a win situation. And so edge computing is very important indeed to make sure that the smaller system can actually act fast and deliver the information quicker than the bigger ones. So even though the quality is a bit lower, you don't always need the best in class in terms of quality to achieve a goal, to achieve an information, especially if you look at early warning or alert mitigation. Usually you want to get to the information with a threshold that is good enough for you to trigger the next action. If you have an information that we like to call them usable information for who has to act on grounds, then that's good enough. So we'll be looking a lot at also phenomena like flooding, forest fires, but also if you want to quickly act on who is polluting which part of the sea, and then try to be quick in sending an alert. Okay, that's happening there. If you get to a level where this information is possible to transfer, and then there are other systems looking at it in more detail, or even vehicles on ground going there, UAVs, airplanes, whatever. That has been always the goal, to integrate our system with the bigger ones. And that's also what's happening now in the new space. Let's say everyone is looking at this, how to augment the bigger system with the smaller ones. And the use of AI on board edge computing is a big asset there. But also we've been looking also how to integrate vertically in terms of from different scales to your phenomena. So from space, from air, from ground. So we've been always looking at integration of the different way of measuring a phenomena with different performance. Sometimes with space and smaller system, you can achieve a very incredibly high revisit. So we have been, let's say, working in issue scenarios with customers only. For example, 12 Hyperscout that Hyperscout exhibits one of the very nice, let's say, features is the very wide SWOT. So we can actually have with one system something like 350 kilometers SWOT, 350 by something like 180, with full hyperspectral plus thermal imaging multispectrum. So you can actually cover this all together. So with just 10 to 12, we're actually able to cover the full globe every half an hour. A tremendous revisit performance. And this means if in that half an hour gap, we are actually able to send down the information, even a few minutes after a single acquisition. So it means every half an hour plus 1, plus 2 minutes, you get information all over the world. That's huge, no? Huge change. And so AI for that, for us, has been one, not only AI. So we have to also make sure that people understand physical models still have a big value in some applications. But the AI has been a big, let's say, parameter shift for us to make sure that this overall view of how to address a measurement problem like indeed early warning was taken into account. And we have been working a lot, let's say, to, as I said, on the pre-processing, also using AI, on the calibration using AI. And then we have been also now, let's say, looking more into actual use cases. Of course, there are the usual suspects that already said, many companies are working on it. So for fire, water, for flooding, for others. But in general, now we're looking also at atmospheric chemistry to see also how indeed we can help pollution. So with hyperspectral. And again, with the view of if you need to do an early warning, then we go for AI, we go quick and we go fast. Then once you have that, you can actually use another system, or you can still downlink the data once they are properly compressed, properly select. So also the selection of the type of data that you need, that can also be done with AI. Also, we do that. So principal component analysis in real time on board. You can also downlink the data that you need, and also the region of interest with the spatial resolution that you need. So you can actually still bring down the data quite quick if you know what you need. That's an important one. So the knowledge of what you need can come also on board by recognizing the phenomena and by recognizing what information needed on ground to actually process them for quality. So these are the two tracks. And then if you downlink this data, there is then ground process. So even, other organizations can actually do a much better use of those data to achieve a better quality. A little bit the schema we have been always looking at. So we've been starting developing, designing, for example, Hyperspectral, looking at this. And then of course you can evolve in any direction. So now we are adding also spectral polarimetry, so you can actually measure the spectral reflectance of light. So you can measure then also the thermal emission of the Earth. So it means you can already get these two parameters. Already you can close the energy budget of the Earth. Then on top of that, you add the polarization state of light. So you can add information on an aerosol, on particle matter, and that also very useful for water quality measurements. And then in the same, let's say, participant suite, you can evolve this at a tremendous release time, and you can detect many phenomena very quick, and then enable the chain on ground. Can be many scenarios, of course.
We've had a lot of interesting insights about hyperspectral imaging and AI so far. Now it'll be interesting to bridge this conversation forward with something around thermal imaging. Nathan, can you talk a little bit about the thermal imaging solution that Cosine provides with T-Scout and its applications today with the data that it can produce?
Hello, everyone. My name is Nathan Verkruijsen. I'm an instrument scientist at Cosine, and I was involved in the development of our thermal infrared imager T-Scout. Temperature and energy are extremely important parameters for many processes on Earth. Accurate maps of land surface temperature are essential for applications in agriculture, water management and irrigation, soil moisture, and water quality. Also, monitoring wildfires provides insight into the consequences of climate change, which leads to higher temperatures, more extreme weather, and higher risk of fire. High temperatures in urban heat islands lead to health problems and excess mortality. Hence, there is a clear need in the remote sensing community for frequent thermal images with high spatial resolution. With the development of T-Scout, we address this need. It is an extremely powerful, compact camera that works in the thermal infrared spectral range. It provides accurate measurements of the temperature of the Earth's surface with a higher spatial and temporal resolution than current systems allow. With novel algorithms and calibration equipment, it provides also unprecedented data quality that is required for the envisaged applications.
I believe Cosine is also using its capacities to work on new technologies such as LiDARs. And you have a particular system called Alert that I'm aware of that can be very interesting to opening up new kinds of data sets for different applications. Nathan, can you please provide a quick overview of the Alert instrument as well as the applications of the data possible?
Indeed, Alert is a single photon counting LiDAR that measures distance. It does that in different colors, different wavelengths, and in that way we can get more accurate spectral and structural information about vegetation, about water, about rivers, etc. In the vegetation, we can distinguish between different layers in the canopy of a forest. We can estimate biomass, carbon capture, and we can understand also the health of the forest and the vegetation. In bathymetry, we can distinguish very clearly between the surface of a river and the riverbed, which gives information on water levels, etc. So in that sense, this will be a very interesting instrument to get more knowledge about our biological systems, biodiversity, and the state of our forests.
Great. I think this has been a fascinating conversation to learn more about hyperspectral imaging, about cosine, the strategies that you're using to productionize Hyperscout, to learn more about AI, T-Scout, Alert, and so on. So finally, Marco, just to end this conversation, I think it'll be very interesting for our listeners and for us to know about what are the current missions that cosine is involved in, and what should we look forward to from cosine in the coming months and years.
Sure, yeah. So indeed, there are many missions we're involved in. I think at the moment we have something like between 10 and 12, let's say, mission going on. What I would like now to focus on are the highlights, let's say, of 2024 launches that we are having, let's say, and let's say the one that has been already launched is a collaboration between Thales and Microsoft. So perhaps that's known to many. So they are collaborating to enable onboard processing for anyone on the Earth. So whoever, let's say, whatever scientists want to process data on board, something that is flying, let's say, in orbit, they want to enable, let's say, indeed, wider community to make sure they get the best algorithms for addressing topics like climate change and others, but exploiting indeed a wider community that's usually quite restricted. Many are trying to open up, but yeah, if there are big players like these ones trying so much, they may succeed. And there, indeed, Hyperscout has been one of, say, the game changer for them. So they already launched. Hyperscout has been already launched on the space station. Indeed, at some point there will be more news. We cannot disclose too much, but in general, this is one of the missions we are involved in. We are very excited to collaborate with these companies and to indeed try to let them achieve their goal that is actually very close also to our goal. Make sure that indeed people can use this data. We can see the change in the community by using our systems. We do with revolutionary breakthrough technologies developed in a nice club like us. But also by others, also very interesting development by other clubs. And that's one. The other one is also very important for the country that is actually having this mission, but also for us to collaborate with a different part of the world. So this is the Australian mission, Canini. This is the first South Australian mission they have. Very nice, I believe, because they organize it very well in terms of a full plan for the usage of the asset. So we have been seeing many players in Europe that, first is launched and then we see what happens, or at least, very, very limited, I don't want to say planning, but in general, it's very limited time that you can actually experience. And then you have to look again for money or for users. In this case, it's fully organized with government. So there are 3 years operations with many stakeholders from government involved for the environmental protection. Again, water, fire, productivity, agriculture. There are many involved. So it means you can really see, we really foresee to see our data used by in the end government to take decisions, and to get there, of course, there are a number of value adders in between. Among those value adders, there is also us that will play some role, of course, in the chain, working closely with our customer. And that's very important for us. This is, let's say, about to be launched in July. This is a sporting level, and we look forward to it. Third one that we already have built and delivered is the Hyperspectral system. So we call it Hyperscout H because it's for the Hera mission. This is the first primary defense mission organized by ESA. This is a mission that goes, let's say, together with the DART mission of NASA. The mission from NASA already happened last year, and indeed, it is all about trying to change dynamics of asteroids, so to preventing that an asteroid can hit the Earth. And after, let's say, the impact provoked by the satellite from NASA, we want then to go into let's say, measuring. So with Hera wants to go there to ESA to measure what happened there. So doing the aftermath. And the Hyperspectral system was not the, of course, important measurement. So you want to see the spectral signature and study what is the composition of the asteroid as well as the crater. Let's say, especially after some time, you can see some effects that happened between the crater that has been created and the rest of the asteroid. And spectral sensing, spectral measurement, that is very important. So we have developed the central spectral system that is on the main spacecraft. So we are not on the CubeSat, we are on the main OHB spacecraft there. Also, that meant for us to be engineering-wise, make a bit of a step on the ECSS part, on the engineering, also because we are outside the satellite deck, so we are completely isolated, while speaking, from the spacecraft. So really we have to take care for ourselves, the thermal balance, the thermal control of the system. So it means that indeed we have full MLI around the instrument, so it looks like a satellite R&D there for the thermal wall and so on. So it's also, the system is a bit bigger, and overall we really look forward to the field operations, because we will see very amazing, I think, images also on the way to the asteroid system, and it's planned to be launched in the Q3. So let's see what happens there. It was October. We have to see what happens now. And of course, as I said, these are the ones we can disclose. There are the commercial ones. Usually it's bounded by NDA, so we cannot tell until the customer somehow start telling it. There are a few, of course, commercial ones, sensitive, we cannot disclose. So it's a big moment for us for the spectral imaging, said by Ivan as well. So we are ready organized for production. So we are ready actually producing batches of systems. We actually have stock. Always we have stock. There is a stock around now, let's say, on our shelves that are ready to be delivered. And soon also we'll come up with some news on this batch for some features that are very important in particular and can benefit for many users. And now we're making, indeed, after that, steps on the LiDAR part. That is for us very crucial. Also there we are on the first implementing LiDAR measurements on satellites for observation of smaller satellite. So this will be also a big, let's say, first time. And I'll leave you are working on it. So thermal imaging as well. So you will hear as well, making bigger system there to achieve better resolutions to let our customers succeed with their mission goals.
Thank you so much, Marco. I believe that it's a great moment for Cosine, having built up heritage, experience, and a brilliant team behind. It's also, I think, a very interesting time in the industry to see how all of these technologies will be adopted to see the Earth observation sector evolve to do greater things, obviously. For all our listeners out there who've been listening to this episode, thank you very much for listening in. We will be linking Cosine's website as well as the portfolio on SatSearch, where you can download all the product data sheets and review the technical information for your reference. I would like to thank again Marco, Ivan, and Nathan for appearing as guests on this particular podcast. And we will be back again soon with your regular host, Hyvel, in a couple of weeks, hopefully, as he comes back from his break. Thank you again for listening to this episode of the Space Industry Podcast. And this is another great company that is taking us all into orbit.
Thank you for listening to this episode of The Space Industry by SatSearch. I hope you enjoyed today's story about one of the companies taking us into orbit. We'll be back soon with more in-depth, behind-the-scenes insights from private space businesses. In the meantime, you can go to satsearch.com for more information on the space industry today, or find us on social media if you have any questions or comments. To stay up to date, please subscribe to our weekly newsletter, and you can also get each podcast on demand on iTunes, Spotify, the Google Play Store, or whichever podcast service you typically use.